take a look at D and E first. Evaluate the composition f of g of negative 3. Begin by inputting negative 3 into the function g. Let's look up here. G of x is 8 plus 2x squared. So everywhere we see an x, we put parentheses. G of x equals 8 plus 2x squared. And now the value being dropped into this g function is negative 3. So we write g of negative 3 is 8 plus 2 times negative 3 squared. Then we evaluate that. Negative 3 squared is 9. So 8 plus 2 times 9. 2 times 9 is 18. And 8 plus 18 is 26. So g of negative 3 equals 26. G of negative 3 equals 26. Well, now 26 is our input that's being dropped into function f. And function f is the square root of 3x minus 12. So f of 26 is the square root of 3 times 26 minus 12. And 3 times 26, 78. And 78 minus 12 is 66. The square root of 66, and we can stop right there. The square root of 66, if you put that in a calculator, it's about 8.124. So f of g of negative 3 is equal to the square root of 66, or about 8.124. All right, let's try e then. We're doing the same thing, except 16 first gets dropped into f. The notation I show for this solution will be just a little different than the way I showed it for part D. But we'll basically be doing the exact same thing. Here we go. Let's evaluate, as they ask, g of f of 16. We'll start by dropping 16 into function f. F is the square root of 3x minus 12. So f is the square root of 3x minus 12. The x value is 16. So 3 times 16 is 48. And 48 minus 12 is 36. And the square root of 36 is 6. So now we need to evaluate g of 6. Well, g of 6 is going to use function g, where the x gets put there, 8 plus 2x squared. So g of 6 equals 8 plus 2x squared, and x is 6. So that's equal to 8 plus 2 times 6 squared, which is 36. And that's 72. So 8 plus 2 times 36, which is 72, which is 80. G of f of 16 is equal to 80.